So, hi! I'm back again. I'm Engineer Jewel Ryan Nicole Birriosa, and I'm here today to discuss modes of heat transfer. But today, we will be discussing specifically the conduction. So, we have different modes of heat transfer, the conduction, convection, and radiation. But here, in my video for today, I will be focusing more about conduction. So, let's start. Here we have three major learning objectives for today. So first, familiarize with the different parameters and properties involved in heat transfer. So we will be able to highlight those properties most especially in problem solving. And then recognize the difference of conduction, convection, and radiation from each other. So I think we will be able to achieve this objective if we finish the videos for convection and radiation also. And then understand the use of formulas of the different mode of heat transfer. So it is a must not only to know what are the formulas but also to realize or to recognize kung saan natin gagamitin ang mga formulas na yon. First, let us define first what heat transfer is. So according to this, heat transfer is thermal energy in transit due to a spatial temperature difference. So whenever there exists a temperature difference in a medium or between media, heat transfer must occur. So again, heat transfer is thermal energy in transit due to a spatial temperature difference. So, temperature difference is a must in heat transfer. Also, we refer to different types of heat transfer process as what I have mentioned earlier, the conduction, convection, and radiation. Those types of heat transfer processes are termed as modes. That is why we have modes of heat transfer. And then in general, all these processes, specifically the conduction, convection, and radiation, occur simultaneously. But one method normally dominates. So again, in general, convection, conduction, radiation occur simultaneously. But only one method or one process normally dominates. Okay? We have here a photo showing the characteristic of conduction, convection, and then radiation. So first, we focus on conduction, the one in the first column saying conduction through a solid or a stationary fluid. So as shown in the figure, we have a temperature gradient or change in temperature. When a temperature gradient exists in a stationary medium, which may be a solid or a fluid, we use the term conduction to refer to the heat transfer process or to the heat transfer that will occur across the medium. So next we have here the image in the middle. Convection from a surface to a moving fluid. The term convection refers to a heat transfer that will occur between a surface and a moving fluid when they are at different temperatures. Again, difference in temperature is essential. And then lastly, the third mode of heat transfer is radiation, or the other term is thermal radiation. All surfaces of any temperature emit energy, usually or in the form of electromagnetic waves. Thus, in the absence of an intervening medium, there is net heat transfer by radiation between two surfaces at different temperatures. Again, the difference in temperature is very important in heat transfer. And I hope you know difference by knowing the definition of conduction, convection, and radiation. But again, we will be focusing on conduction on this video. So let's go. Focus on it na. So let's first define conduction. Conduction is the transfer of heat by direct physical contact. By mention of the word conduction, we should immediately think of concepts about atomic and molecular activity. These processes are related to conduction because the molecular activity sustains the mode of heat transfer, most especially in conduction. Conduction may be viewed as the transfer of energy from the more energetic to the less energetic particles of a substance due to interactions between the particles. For example, since conduction is transfer of heat by direct physical contact, when we have direct physical contact, it usually, or most of the time, it results in collision between molecules, thus having energy transfer. So the collision, we have direct physical contact. The direct physical contact results in collision between molecules and thus further having energy transfer. Molecules in object at higher temperature have higher average kinetic energy and vice versa. So I hope that's quite enough for the definition of conduction. We have here the formula. So it is possible to quantify heat transfer processes in terms of appropriate formula or rate equations. These equations may be used to compute the amount of heat transfer or energy being transferred per unit time. So for heat conduction, the rate equation is also termed as or known as Fourier's law. As you can see in the figure, for the one-dimensional plane wall shown in the figure below, so the figure, having a temperature distribution Tx or T of x, the rate of equation or the rate equation, the formula is expressed as Qx is equal to negative K dt over dx. So, next slide, I will be giving you the details or the nomenclature of what is Q, what is negative K, what is dt over dx, why is it negative. So, let's proceed. So first, we have here Qx, which is what we call the heat flux. Usually, the unit is watt per square meter. It is the heat transfer rate in the x direction. That's why it is termed as Qx, or the abbreviation is Qx. Heat transfer rate in the x direction per unit area, perpendicular to the direction of heat transfer. Again, perpendicular to the direction of the heat transfer. And it is proportional to the temperature gradient dt over dx. So, we have the heat flux and then we have temperature gradient. The parameter K is what we called a property, what we termed as thermal conductivity. This thermal conductivity unit, watts per meter Kelvin. This is a characteristic, usually it is a characteristic of the wall material. The minus sign or the negative sign is a consequence, or the reason behind this negative sign is the fact that heat is transferred in the direction of decreasing temperature. So again, this is negative because heat is transferred in the direction of decreasing temperature. I hope that's clear. More details about our temperature gradient is provided here. So under the steady state conditions where the temperature distribution is linear, our temperature gradient may be expressed as So again, our dt over dx, our temperature gradient, may be expressed as change of temperature over length. So if our dt over dx or temperature gradient is change of temperature over length, our heat flux formula will be negative of thermal conductivity multiplied by the change in temperature over length. Note that this equation provides only for, the equation provided here is for heat flux only. That is the rate of heat transfer per unit area. If you want to know the heat rate by conduction, you have to multiply the area here. So again, this is heat flux, the rate of heat transfer per unit area. If you want to know the heat rate by conduction, you have to multiply the area. I hope that's clear. Now that we are knowledgeable about the formula about conduction, I think it is time to solve some sample problems. So the question goes like this. The wall of an industrial furnace is constructed from 0.15 meter thick fireclay brick having a thermal conductivity of 1.7 watts per meter Kelvin. Measurements made during steady-state operation reveal temperatures of 1400 and 1150 Kelvin at the inner and outer surfaces, respectively. What is the rate of heat loss through a wall that is 0.5 meters by 1.2 meters on a side? So, I will be showing you a systematic solution of this problem. So, I follow this format in the book of Mr. Frank P. Incorpora. I think the title is Mass and Heat Transfer. So, the entire solution goes like this. Known first steady state condition with prescribed wall thickness, area, thermal conductivity, and surface temperatures. And then find what is required. We need to find the wall heat loss. Schematic diagram. So we have here the schematic diagram with all the given, which is the temperature, the thermal conductivity, the length. We can solve for the wall area because the dimensions are also provided. And then assumptions, steady state conditions, one-dimensional conduction through the wall, and then the thermal conductivity is constant. Since heat transfer through the wall is by conduction, the heat flux may be determined from what we call the Fourier's law. So we have heat flux is equal to negative of the thermal conductivity multiplied by the change in temperature over length. So we just need to substitute the given because everything is given. Our heat flux is 2,833 watts per square meter. But the question is, again, this is the solution highlighted that the heat flux represents the rate of heat transfer through a section of unit area. And it is uniform across the surface of the wall. But the question is the heat loss. So the heat loss through the wall of the area is then, so we have the heat flux, we need the heat loss, and we have also the dimensions for the area. So we just need to multiply the heat flux with the area. So we have 1,700 watts. Comments or conclusion you may also provide for a more comprehensive solution. So the comments that is provided here is note the direction of heat flow and the distinction between heat flux and heat rate. So yeah, it is a must to know the distinction between heat flux and heat rate because you might have the final answer as heat flux, but then what is, What the correct answer is 1,700 watts, which is the heat rate. So, you always need to be careful, or my suggestion is to always check the question, read, note that the question is heat rate, or please note that the question is heat flux. If the question is heat flux, then you stop at, you don't, even if the area is given, you don't need to multiply to the area to get the heat rate because the question is only heat flux. But then in our sample problem here, the question is about heat rate. So, fortunately, we have the area. That's why we can solve for everything. So, I think that's all for today, and I hope I help you a little bit in heat transfer, most especially in conduction. So, if you wish to have a copy of this PowerPoint presentation, and if you also have some questions regarding the topic, kindly email me at ryannicole05@gmail.com. So, yeah. Don't forget to subscribe. Thank you.